go downhill very quickly. So I want this next test to go well for you. You're all welcome to come. If you have a C- or better, you need to come because that means something's not clicking quite right. And we want to make sure it clicks before the test. So this is not a punishment. It is just an encouragement to help you understand. Okay. You may come in person. You may come on Zoom. I don't care, but 9 o'clock Friday morning. Okay. Okay. Let's do 10-8 unless anyone has questions on any of that. Okay. Let me pull this up. Distract the entire class if you do that. All right, go time. Here it is. So 10-8, when you're doing probability, you've probably learned this concept before. We are always going to write it as the probability, capital P, of some event. Okay, whatever we're trying to find the probability of, that's going to be in parentheses there. You guys good back there? It's not loading. None of you? Oh. Anyone want to airdrop? Who's got it? Samara. You're going to airdrop? Who needs it? So I can tell Samara the names she needs to airdrop. Tyler and Ari. Is that it? Just 2 now? Okay. You don't see Tyler?
Oh, wait, actually,
Got it. Are we good now? Everyone's got it? Okay. Thank you, Kayla.
yeah, they're kind of a lot in the March, so I don't want to squeeze all.
Okay. No, that's great. Thank you.
Yeah.
Oh, Claire is on there. She's doesn't even go here anymore. Sad. Sad day. Do y'all wear green today? I don't see any green. Oh, there you go. Oh, you're telling people you're wearing green socks, but you're not. Anyway, okay, here we go. So when we're talking the probability of some event, you're always going to write what that something is in parentheses behind the P. Okay. So if I say the probability of rolling a 6, we're going to write the probability of rolling a 6. Okay. That's how we write it, just in the like standard form. The way we find that probability is we take the number of favorable outcomes, like the things that, so in this case, favorable would be rolling a 6. So the number of times you roll a 6 out of the total number of possible outcomes. So every time you rolled counts as a time, right? Your number of possible outcomes. So that's the concept that we're going to use throughout the lesson today, is the favorable over the possible. Okay. So first example, it says a gnat lands at a random point on the ruler's edge. So it is going to land on the ruler. Okay. That's key. If you don't state that, probability changes drastically, right? So if it's going to land for sure on the ruler, find the probability that it lands between the 3 and 7. Okay. So our favorable right now is between 3 and 7. Okay. So we're saying, what's the probability that this gnat lands? This is my between, by the way, B/T, between 3 and 7. Okay. So I want favorable over possible. Anyone know what my favorable number would be?
5.
Which is not 5, but I know why you said that. That's 4 inches, right? Between 3 and 7. So my favorable is 4. What's my possible? 12, the whole ruler, right? He could land anywhere between 0 and 12. So there are 12 inches for him to land on. So 4 over 12, or we would reduce that to 1/3. So the probability that a gnat lands between the 3 and the 7 is a 1 in 3 chance. Okay.
Miss Raven,
Yes.
I have a question. I'm kind of confused how you got the 12.
So it's your total possible, the number of possible outcomes. So we have a ruler that goes from 0 to 12. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total inches that it can land on. The favorable is the 1, 2, 3, 4 between 3 and 7. So favorable is
Okay.
4, total possible is anywhere on that ruler, which is 12. That make sense?
Yeah.
Any other questions on that one? Okay. Example 2 then. It says Elena's bus runs every 25 minutes. If she arrives at her bus stop at a random time, what's the probability she'll have to wait at least 10 minutes? And we have lots of time today. So I'm going to give you a minute just to see if you can figure this one out. It's kind of hard with the way I set it up with the 0 to 25. If you don't kind of rearrange your brain a little bit, but I'm confident that you can figure it out. So see if you can figure out what's your favorable, what's your possible. You would write it, the probability that you wait at least 10 minutes is what? Anyone want to give their answer?
Is it 3/5?
Who did that? Jada?
Yeah.
Beautiful. It is 3/5. Did anyone get 2/5? That's the one that is very tempting to do. Okay, so here's how I want you to think about this. You have the bus leaves here, right? So a bus leaves the stop and then 25 minutes later, it comes back. Right? So if we think of it that way, the question they're asking is, what's the probability she'll have to wait at least 10 minutes? So let's just think about a couple places here. If I get to the bus stop right here, how many minutes am I waiting until the bus comes back? 5 minutes. Okay. If I get there right here, how many minutes am I waiting until the bus comes back? 10 minutes, right? This gap right here is 10 minutes. So this is the point where you wait exactly 10 minutes, but it says at what point, or that she'll have to wait at least 10 minutes. So 10 minutes or 11 or 12 or 13 or 14 or 15 and so on and so forth. All of this is waiting 10 minutes or more. Okay. So that means my favorable is 5, 10, 15 minutes. Okay. So my favorable on top is going to be 15. What's the total possible? 25 minutes from start to finish, 25 minutes for, oops, not 15, 25. So 15/25, we would reduce that to 3/5. Sometimes people like to write probability as a percent. That's fine. You would just divide that. 3 divided by 5 is 0.6. 0.6 as a percent is 60%. So it's a 60% chance that Elena has to wait 10 minutes or more for the bus to come. Does that make sense? Okay. Okay, so here's where more of the geometry comes into it. Now we're going to talk area again, and you guys have done area, so you should be really good at this now. It says, what is the probability of something landing in the shaded region? So basically what we're saying is, let's say we're throwing darts, okay? If I'm going to throw a dart and it's going to hit within the square, that's the part that matters. Otherwise you could say, well, landing there versus landing across the street, very different numbers. So it's gonna hit in the square. What's the probability it hits the shaded region? Any ideas how we can figure that out? How do you find a value for the shaded region? What are we finding? It's area. Yeah, we're finding the area of that shaded portion. So basically what we're saying, if we're doing the favorable over the possible, right? That's just our formula again. Our favorable, portion is the shaded part of it. What's our total possible? What figure?
The square.
It's the square. Yeah. So basically what we're doing right now is we're finding the area of the shaded and dividing by the area of the square, right? That's our favorable over our possible. So to find the shaded portion, what do we have to do? Area of what? We're going to start with square. The shaded portion will be the square minus the circle, right? Would give us the shaded part of it. So we're going square minus circle over square. So let's start just by finding the areas of those things. The area of the square is what? 36, 6 times 6, right? Base times height. This would be 6 and this would be 6. So 36 square centimeters is the area of the square. We just did 6 times 6. What's the area of the circle? What's your radius? It's 3, right? If the diameter here has to be the same as the side of the square, then my radius would have to be 3. So the area of the circle, we're going to do pi times the radius squared, or 9 pi square centimeters. Okay, so what we need to, yeah.
So for the a squared, so that will represent us in the formula for area, but and then for the a circle, that we're doing the formula for the radius.
Area of the
Well,
square and area of the circle. So area formula for a circle, area equals pi r squared. So we did pi times a radius of 3 squared. So you're just plugging it into pi r squared.
And a squared is the base times the height.
The area of the square would be the base times the height. Yeah.
Okay.
Okay. Okay, so let's plug it into this concept then. We're going to say the area of the square, so 36, minus the area of the circle, which is 9 pi, divided by, I didn't write this in. So the probability we hit the shaded section, 36 minus 9 pi divided by the square again, which is the 36. So I would plug this into your calculator right now just to make sure you're plugging it in correctly. Because honestly, that's where a lot of silly mistakes get made, is just how you plugged it in. So plug in 36 minus 9 pi and then hit enter and then divide by 36, because otherwise your calculator might think you're saying 9 divided by, or pi divided by 36 and then subtracting. We don't want that. So 36 minus 9 pi. Actually, I'll just give you that number. You don't need to write this number down for me, but I'll show you what it is just in case you're not sure. So you end up on top with 7.7257. On bottom, you have 36. So just divide by 36 and you get this number. Okay. What does that mean? What is 0.2146? The probability we hit the shaded area is what? Remember what I said? Sometimes people, instead of giving a fraction, they'll give what? Percent, okay? So if we turn this into a percent, you're gonna multiply by 100. So it's about 21.5%. So the probability you hit that shaded region is about a 21.5% chance. Does that make sense? Okay, so favorable over possible. All right, this last one is the fun one. Lots going on here. It says, what is the probability of landing in the black, red, and yellow region, okay, as three separate probabilities. What's the probability we land in black? What's the probability we land in red? What's the probability we land in yellow? If we are going to land within the square, and I apologize, this is not drawn to scale, but I was trying to keep it not so huge. So pretend that this looks drawn to scale. My 12-inch by 12-inch square should have been much bigger, but we're going with it. Okay, let me find my yellow here. The first thing I would do if I were you is I would just find the area of everything we have here. So there's a square and there's three different circles. So let's find the area of the square. Okay, what would the area of the square be? 144, 12 times 12, base times height, or 144 square inches. Okay, so that's our square. Then let's do the yellow circle. Okay, area of the yellow circle. What would that be? What's the formula for the area of a circle? That's circumference. Pi r squared, right, is area. So we're going to go pi times 1 is the radius squared, which is really just pi square inches. Okay, so the yellow circle has an area of pi. The red circle, now I'm not asking for the red portion that you see. I'm saying, what is the area of the red circle? If we did the whole circle, what would the area be? So really I'm looking for the area of all of that, right? So the area of the red circle is going to be pi times what? 2 squared. Yeah, your radius now is 2, right? It's from here to here. Can't really see that, can you? Here to here. So pi times 2 squared, or 4 pi square inches. Okay, so that's our red. And then the last one is we're going to find the area of the black circle. What's your radius for your black circle? 3. So pi times 3 squared, or 9 pi square inches. Oh, sorry. So that's all the information that you need to be able to solve this problem. Now we got to figure out how to apply it to the problem. Okay, we know all the areas of the different things we have. Let's start with yellow, because yellow is probably the easiest one. What's the probability that we hit yellow if we throw a dart and hit this board? What's your favorable? What are we trying to hit? Remember, this is always our favorable, right? Whatever's in the parentheses is your favorable portion. So what are we putting there? Pi, yeah, just whatever the area of our yellow circle is. So your favorable is the yellow circle, okay? Over the total possible. What's the total possible in this problem? Right, the area of the square, the 144. So favorable over possible is pi over 144. If you plug that in, you get this number, 0.0218. So the probability that I hit the yellow circle is what? Give me a percent. 2.2 if we round to the nearest 10. So 2.2%. Okay, that's the probability that you hit yellow. It's the circle over the square. Okay, all right. Next one gets a little bit trickier. It's not bad, but a little bit. So the probability that we hit the red portion now. Now we found the area of the red circle, but that's not what we're trying to find the probability of. What's the probability that you hit the red area? What do you do? What do? You subtract the yellow from the red. Yes, we're going to subtract. Okay, so we're going to go red minus yellow over the square, right? So it's going to be 4 pi minus pi over the square, which is 144. And then you just simplify that. 4 pi minus pi is what? 3 pi. So we're going to say 3 pi divided by 144. And when you divide that, you get 0.0654. So the probability that we hit the red region would be what percent? 6.5%. We just take that 0.0654 and round to the nearest, well, multiply by 100 and then round to the nearest 10th of a percent. Okay. Okay. Now black. And black is the one where I get several different answers usually. Let's see if you can figure out the right one. If we're going to find the area of the black region, what are we doing?
Minus red square, red circle and yellow circle.
A lot of people say that, but that is not correct. We're not going to take both circles away. Why not? The red circle is all of this, right? We found the area of the red circle and that included the yellow portion. So what you're going to do for this one is you're going to do the probability we hit black is going to be the black circle minus just the red circle. Okay, so don't subtract the yellow one too. It's very tempting to do. A lot of people do it. Don't do it. And we're going to divide that by the square. Okay, so black circle is 9 pi. Red circle is 4 pi. So 9 pi minus 4 pi over the square, over the whole thing, which is 144. So if you plug that in, you get 5 pi over 144. And you get 0.109. So the probability that we hit the black area is about a 10.9% chance, right? We take that 0.109, we move it 2 decimal places to the right to turn it into a percent, and that's our percentage. So really, if you think about this, this is how you can really tell that my picture is not drawn to scale. 10.9% and 6.5% and 2.2%, that works out to like 19%. That means this whole circle here is 19% of the whole square. It's not drawn well, but you get the idea. Any questions on that? Okay, that's essentially what you're doing today. I would like to spend some time going over anything you're not sure about yet at this point. Friday is just kind of a review of the first half of the chapter. Next Monday is a review of the whole chapter. And then Wednesday, you're taking the test. And I want to make sure you are totally ready to go for that test. So if there's anything, we'll start with yesterday's stuff, 10.6, 10.7. If there's anything you have questions on there, ask away. If you have questions on 10.3 or 10.5 or before that even, I'm happy to do those too. But let's start with 10.6, 10.7, just because those were the most recent ones that we did. And if you feel totally good about 10.6, 10.7 or all of it, you are welcome to get going on the homework. But I highly recommend if you didn't understand something that you stick around and ask away. Why don't we start? Well, I don't care. Anyone have questions on 10.6 or 10.7? You can start wherever you need to. Nicholas.
10.7, like 30 and 38, I think.
30 and 38 from 10.7. Okay, and I'm gonna just draw pictures because every time I take pictures, I have to rearrange and it's just a pain. So I'm just gonna draw pictures for you. Hopefully they'll be good ones. So number 30 on 10.7 starts with a square that has 2 semicircles. Pretty good, you guys, man. Doesn't happen very often. Okay, so it looks like this. They give you that this is 8 feet. This is 8 feet. Oh, sorry, the dots are there. So it says find the area of the shaded region. Okay. This was supposed to lead you into what we just did today, essentially. If I put these two pieces together, what do I get? It's a circle, right? They're just butted up to each other backwards. So basically what we're doing to find the area of the shaded region here is we're just taking the area of the square minus the area of the circle. So what would the area of the square be right now? 64, 8 squared. And then take away the area of the circle, and the area of the circle is going to be pi times the radius squared. What is the radius of your circle? It would be this, or it would be this. It's 4, right? So they gave you a diameter by giving you the side of the square. So your radius would be 4, or half of that. So pi times 4 squared. So you get 64 minus 16 pi. What did they ask? Simplest radical form. That would be your answer, actually. You can't combine those. So the area would be that. Now, if they said round it to the nearest 10th, you would just plug that in, 64 minus 16 pi, and you would get a decimal. What was the other one you said? 30?
The last question, 38.
38. Okay, 38, they tell you the circumference is 26 pi inches, and they want to know the area. Okay, so think about this. Circumference is pi d, or circumference is 2 pi r. However you want to figure it. Area is pi r squared. Okay, so if we're trying to figure out the area, we need to know the radius. Well, we know the circumference, but we don't know the radius. So we're just going to plug it into this. 26 pi equals 2 times pi times the radius. We're plugging it into the circumference formula. So we would divide by 2 pi. Divide by 2 pi. So pi divided by pi is 1. 26 divided by 2 is 13. That is 1. So our radius is 13, which means the area of the circle is pi times 13 squared, or 169 pi square inches. Okay. Any other 10-7? Oh, let's see. None. Tyler, what do you need? None on 10-7? You're good on 10-7?
No, yeah, I'm good on 10-7
Okay.
now. I just needed one area thing. Thank you. So
Okay,
I feel
so
in 10-6
28
though.
30.
Yeah.
Okay, so 10-6. $28 and $30. Okay, 28, they're talking about problem 3 in the book, which I'm actually going to take a picture of. So you're going to have to bear with me because this is going to probably make me delay. Okay, so this says the camera dolly track in problem 3 can be expanded so the diameter of the outer circle is 70. Okay, diameter. That means this whole distance across is 70. How much farther will a wheel on the outer rail travel during one turn around the track than a wheel on the inner rail? So this is still going to be 2 feet, which means if this is 70 right now, you have to take, for the diameter of the inner wheel, you have to take off that 2 feet on both sides. So if the whole thing is 70, the diameter of the bigger, then the diameter of the smaller circle is what?
$66.
Yeah, you would do 66. We got to take away 4 and 4, so take away 8. Sorry, I said that wrong. 2 and 2, so take away 4. So we have the diameters of both. It says how much farther will the bigger wheel, the outer wheel go. So you're going to do the circumference of the bigger circle would be pi times diameter, so 70 pi. The circumference of the smaller circle, also pi times diameter, so 66 pi. Okay, how much further means you just have to subtract them. They're just looking for the difference between them. So 70 pi minus 66 pi is 4 pi feet. So the outer wheel would go 4 pi feet further. Now that's a weird answer. So we typically, when it's a real world type of answer like that, just plug it in. 4 pi is about 12.6 feet further. Okay. And then number 30. Okay, 30 is finding the length of an arc. And that's a formula that you're going to use. I highly recommend you guys. Have you been using that formula sheet that I gave you? I put it in 2 places so far. You should use it. Use it every single time you do your homework because you're going to use it while you do your test. And if you don't know them doing the homework, like if it's not easily accessible there, then when you see it for your test, it's going to be more difficult. So highly recommend that you use it. Let's see. So we have a circle. And you have from the center, they tell you this is 45 degrees right here. And this is 14 centimeters, okay? They're asking you for the length of this arc. So the black, how long is that black arc? So arc length, the formula, which is on that sheet for you, is the measure of the arc over 360 times the circumference of the circle, so times pi d, or you can do 2 pi r, okay? Which means the measure of the arc is 45 over 360 times pi. What's your diameter going to be right now? 28, double it, right? So if your radius is 14, your diameter is going to be 14 more, so 28. This is what you're going to plug into your calculator. 45 divided by 360 times 28. Do that. You get 3.5. And you maybe got this and the book says this. I don't care if you tell me 3.5, as long as your answer isn't rounded. 3.5 pi, I'm fine with. If it's 3.4279, then leave it as the fraction, but this is totally fine. And this would be centimeters because we're talking length. So not square centimeters, it's not area. So that would be your answer, arc length. Any other questions? Don't be bashful. 10-3, 10-5, any of it? Those ones were tough. SOHCAHTOA. 36 for 10-6 and 38 for 10-7. Yes. Okay, so 36. Oh, yes, this one's a fun one. See how delayed we are here. Excuse me. So it says Nina designed a semicircular arch made of wrought iron for the top of a mall entrance. The 9 segments between the 2 concentric semicircles are 3 feet long. So all of these they're saying are 3 feet long. 3, 3, all the way around. Okay. What is the total length of wrought iron used to make this structure? So what you're doing here, it says they're semicircles, which means they're half of a circle. So I can figure out the arc length by saying 180 is my arc, right? Because it's half of a circle. So 180 over 360 times pi times my diameter. That would be my arc length. So times 20. That's going to find me this arc. Okay. This one, the purple one now, is going to have a different diameter. What's the diameter of that one going to be? So if this is 3 feet in between each one, then this would have to be 3 feet here and 3 feet here, right? So if that's the case, this distance across is now 26. So you're going to do the arc over 360 times pi times 26 for that one. And then get this out of there. It said you also have those 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of metal that are each 3 feet long. 3 feet, yes. So 9 times 3 is 27. So we need 27 feet of wrought iron for the in-between. We need, this would work out if you plug this into your calculator, that's 10 pi for that one. And then this one, if you plug this into your calculator, that's 13 pi. So you have 10 pi feet, 13 pi feet, and 27 feet that you have to add all together. So add that all up. 10 pi plus 13 pi plus 27 comes out to 99.256 is what I'm getting. So you would need just over 99 feet of wrought iron for that to work. There was another one. Oh, 38 on 10.7. Okay, this one they tell you the circumference of a circle is 26 pi inches, and they want to know the area. Okay, so think about what you know for circumference and what you need to know for area. Area is pi r squared, right? Circumference is either pi d or 2 pi r is your formula. So if we're looking for area, we're looking for a radius. So I would probably just use this formula because that has the radius in it. You can use this one and then just cut it in half. That's fine too. So we would say circumference 26 pi equals 2 pi r, and then solve for r. How do you solve for r here? We're just going to divide, right? Divide by 2 pi, divide by 2 pi. So this is gone. Pi divided by pi is 1. 26 divided by 2 is 13. So we have a radius of 13 and we're looking for the area. So that 13 is going to go here. Pi times 13 squared is 169 pi square inches because it's area. Okay.